So let's do some examples. Because the first thing I want to make sure that you all get is the difference between correlations and the other stuff that we've been doing so far. Okay, so we're going to do social media use. And let's say I'm going to recruit a sample of like just y'all, college undergrads. I'm going to have you log how much you use specifically social media for, let's say, a month. And then at the end of the month, and maybe my question is, I think college students use social media more than regular people. At the end of that month, I'm just going to tabulate, right, everybody's hours, how many, what's their average number of hours per week that you use social media, okay? And then I'm going to just report on that. I'm clearly just measuring that variable. First, do what type of claim is this, all right? Your options are frequency, association, or causal. What do you think that one is? Okay, so everybody's saying frequency. You're right. Now, what is the key thing that tells you it's a frequency claim? Great. Okay, so some of y'all are pointing out what kind of statistic I'm reporting. So I'm just reporting an average and a standard deviation. So absolutely. So that would be a descriptive. We're literally just doing measures of central tendency. There's only one variable. All of the other kinds of claims, the other two types of claims, you have to have more than one variable. The only one where there's only one variable, frequency claim. So this absolutely has to be a frequency claim. So then let's talk about how we would change that into a correlation. The key part of how we change that into a correlation is that first, we're going to need a second variable. So if we keep variable number one as social media use, we're going to have to pair it with another variable, okay? So we would need variable number two. Both of the variables in a correlation have to be measured. So whatever we pick also has to be measured, because in a association claim, which is what this is going to be, because correlations are always association claims. There's other ways that you can establish association claims, but correlations are always association claims and never causal claims. Is that you would have two things, and you're just seeing, are they in a relationship with each other, right? Or not. And then if they are in a relationship with each other, what kind of relationship is that? We have to have two. They're just measured. Nothing is manipulated. The manipulation part comes when we get into causal claims. So causal claims are when we have something that's manipulated. So we're not manipulating anything yet. We're just measuring stuff. I'm going to go ahead and grab a new variable. I'm going to say we're going to do loneliness. It's a classic one when we look at social media use. And we're going to make that a score on the UCLA loneliness scale, which is a real thing. And our social media use, remember, that was going to be an hour log. So they're both measured. We can already say, the type of claim, because I already mentioned it, right, is association for all the reasons that I just said, okay? Let's say what we're going to do is we're going to have a sample of college undergrads. We're going to have them do the same thing. They're going to log their social media use for about a month. That way we can kind of see how things ebb and flow over time, right? And then at the end of the month, they take this loneliness scale. And what we're looking for is there a relationship between social media use and loneliness, specifically for college undergrads? Okay, so that's our little blurb. We talked about hypotheses. So let's do some hypothesis stuff. So if I had a hypothesis that was there is no relationship between social media use and loneliness scores in college undergrads, what type of hypothesis would that be? Is that a null hypothesis? Is that a research hypothesis? Which one of those is that? This is our null hypothesis, so that's H0. Right? We make the little zero there a subscript. Okay, so H0, this is our null hypothesis that there is no relationship. And again, the key word there is no, because a null hypothesis is some kind of statement of no or none. So then let's write a research hypothesis. Well, given the research, right, I'm going to go with there is a positive relationship between social media use and loneliness. Okay, positive relationship. So your new question then, is that a directional or non-directional hypothesis test? It's directional. What's the key word that told you it's directional rather than non-directional? Right, positive, exactly. It's directional because I've picked a specific direction. If we wanted to rewrite that into a non-directional one, we would have it like this, where I would just say there is a significant relationship between social media use and loneliness scores, right? That would be non-directional, because I'm not going to say what kind of relationship it is. It could be positive, it could be negative. I'm just saying there will be a relationship rather than no relationship. That's a non-directional hypothesis. Great. And then our final kind of question then is, if we go with our, I'm going to move this around a little bit, right? We're going to keep it's going to be a positive relationship directional hypothesis. So what type of hypothesis test then is this? Is this a one-tailed or two-tailed test? It's a one-tailed test. Remember the reason why. Go for our drawing tool here. Okay. We've got our normal curve, right? It's got two tails. If I'm looking in a specific direction, then I'm only going to look in one tail, right? So one tail test, directional hypothesis, right? I've picked a specific direction. So I'm only going to look in just the positive tail there to see, is that where my results are? So if it's here, it's no good. If it's here, no good, right? It's got to be here for it to work, okay? If instead we went with that the non-directional hypothesis, where we're like, hey, it's going to be a relationship, that's when I can look in both tails, right? And so if it's here, we're good. If it's here, we're good. But if it's here, it's not. If I've picked a direction, one direction, if I picked a direction for the results, one tail test. If I'm leaving it open, non-directional, right, then we're going to look in both. So that kind of sets up how we can think about moving from frequency claims to association claims, and also review some of the stuff from last week about hypothesis testing. Let's talk about what would happen based on what we found. So let's say I do this test, right? Like I do this research study and my results. Let's say I find that there is a significant relationship between social media use. Well, that means I know that there's something, I know that my null hypothesis is not true, because anytime you do a correlation, you've got three options. The first option is that there is no relationship. There is no correlation, okay? So if I find that there is a significant relationship, I already know there's not a null, okay? So again, we're supporting that alternative hypothesis rather than null hypothesis. If I don't find that there's a relationship, what does that mean? That means that the variables are not related to each other. If the variables are not related to each other, we keep the null hypothesis, right? And it would mean in this case that loneliness and social media use are not related to each other in college undergrad, which would be weird since they're related in lots of other research studies that we've done. We can have a positive relationship or we can have a negative relationship. And sometimes we hear the words like positive and negative and we think good and bad, right? And that's not what this means. For positive relationships, I want you to think in sync, right? So in sync with each other, right? And negative relationships, I want you to think opposite. So in a positive relationship, the variables vary in the same way, meaning that if one goes up, one increases, the other one's also going to increase, okay? They move in sync with each other. The other option would be for there to be a negative relationship. And again, that just means that they have the opposite relationship, okay? So they move in opposite directions for each other. So they're still related to each other. Variables are related to each other, right? Vary in an opposite way, right? So as one increases, the other decreases. As one decreases, the other increases. So what we're doing is, hey, is there a relationship here? If there's not a significant relationship, two variables are not related in this particular instance. Doesn't mean they're not ever related to each other, because one study doesn't prove anything. One study just lends support for something. In this one study, these two variables are not related to each other significantly, okay? Or we find there's a positive relationship, and that means they vary in the same way, they vary in sync with each other. So as they go up, they both go up, right? Or they have a negative relationship with each other and they move in opposite directions. As one goes up, the other one goes down, okay? So again, in these cases, if we found that it was a positive relationship, as loneliness goes up, social media use would go up. We're not saying that loneliness is causing the social media use. We're not saying the social media use is causing the loneliness. because we're not manipulating anything for a causal claim. We're just saying these two variables are moving together in the same way. They're moving in sync, okay? Or we can find there's a negative relationship, which is as loneliness goes down, social media use goes up. That doesn't really fit with the research, but it's possible. I'm going to switch the window from our notes to the PowerPoint. And there's a couple of PowerPoints in your module this week. There's this one that's just about concepts related to correlations. There's one on how to hand calculate a correlation. That's the one where I've already recorded you a video lecture. And then there's one on regressions. Correlations, we talked about what their purpose is, right? We're looking to, is there a relationship between them? These are for association claims. There's two variables and only two variables. They're both measured. We talked about that the options are either no relationship or positive or negative. Here's the thing I haven't said yet, because we haven't really gotten to the math part, right? Which is that correlations range from -1 to +1. So +1 would be a perfect positive relationship, and -1 would be a perfect negative relationship. They cannot be any number greater than that. So what that means is that when you are working on a hand calculation, like you will have to do for the homework, and you finish your hand calculation and your answer is 4.86, you know you've messed up somewhere, because it literally cannot be greater than positive or -1. It cannot even be 1.01. Literally, it has to be between -1 and +1, somewhere in there. The closer to 0, the weaker. The closer to positive or -1, the stronger. All the way to where positive and -1 are considered perfect. And because they're perfect, they almost never exist in human research, right? Sure, if you're running mathematical models out of the math department, you might get things that are perfect correlations. We don't see those kinds of numbers in like human research and stuff like that. So instead, we talk about strong, moderate, weak, right? That sort of thing. And we're not looking for perfect. We are looking for significant. Already talked about directions. Now you can also do this by looking at scatter plots. Now here's the deal. In Dr. Wolf's class, if there's a relationship on that scatter plot, it will have a line, okay? So if the line's going upwards, positive. If the line's going downwards, negative. And in Dr. Wolf's class, if there's no line, no relationship, okay? Other people's classes may literally show you multiple different kinds of scatter plots and have you figure it out without the line, okay? I'm not going to do that to you. We got a lot to cover. We all make choices about what we're going to cover and stuff, and so that's what so I'm not going to have you do that skill. So I mentioned that because +1 and -1 are perfect, and we very rarely see that in reality, we instead use what is Cohen's D, the same numbers for Cohen's D, to kind of decide whether or not something is small, medium, or large, okay? If your correlation is 0.5 or more, we consider that pretty large, okay? And so if you've got 0.7, 0.8, all of those are going to be large. Those are going to be great, okay? Because again, getting all the way to 1.0, very unlikely in humans, okay? So we're really just shooting for 0.5 for it to be large. Then if you're between that and 0.3, right, you're kind of medium. And if you're between that and 0.1, you're weak or small, okay? And then those are just numbers that you might have to commit to memory. These are for association claims. We only use correlations for association, not for causal claims. Causal claims require 3 things. The first thing it requires, right, is to covary. That's what correlations do. Correlations do the first part. They say, yes, variable A and variable B are related to each other in that they vary together, they covary. But it doesn't do 2 and 3, which are required for a causal claim. There isn't temporal precedence, which is just a fancy way of saying you know which one came first. You have to know that the cause came before the effect. We don't know that when we're just measuring 2 things. So back to loneliness and social media use. I don't know if that person was inherently lonely and that drove them to increase how much time they were spending on social media, which may have further isolated them from any social contacts that they had outside of social media, which may have exacerbated the loneliness. Or that they fell down a rabbit hole in social media, and then that's what caused the loneliness. I don't have temporal precedent, so I can't have a cause and effect there. The other thing they don't have, correlations don't have, is internal validity. And what I mean by that is we don't know if there's another variable up here that's actually explaining both things. Okay. It's kind of like we put on blinders, right? When we do correlations, we only look at two things at a time. So we would miss if over here, right? Like if I can only look at these two things, I would miss if over here there's something that's actually explaining both of them. Like with this loneliness social media example, I don't know if there's an inherent social skills deficit that's explaining both. I don't know if there's a depression score that would actually be explaining both. I don't know if there's a stress score that would actually be explaining both. There's all sorts of other variables that might be explaining both. Association claims and correlations are still valid. They're still important because we need to know, are things actually related? Because if we don't know that because we've tested it, we tend to just rely on our assumptions and biases. And so when we do that, we say things like, oh yeah, blah, 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 blah. These things are related to each other. And then they might not be. Okay. So we do need to know when variables do co-vary. But we can't assume that just because two things co-vary, that it's a cause and effect relationship. Just like there's lots of kinds of relationships you can have with people, not all of them are marriages, right? Not all of them are romantic. So like you have a relationship with your friends, your romantic partner, your parents, the person that you see every day in class, but you're not really sure what their name is, right? And you're not really friends, right? Those are all different kinds of relationships, but only one of them is romantic. There's lots of different kinds of ways that variables can co-vary, but not all of them are going to be cause and effect relationships. Okay. So just remember, correlation does not imply causation. And then I think after that we go into prediction. So again, what we're doing here is we're seeing if two variables are related to each other. Okay. If they are, we can then make predictions. Okay. So if they are not related to each other, we cannot predict. So zero association, no prediction, right? But if we can, if there is a relationship, then we can make predictions. And so because there's just two variables, that's an XY axis. What we're doing, again, going back to those scatter plot ideas, is that you are literally plotting each person's score, what they got on variable 1 and what they got on variable 2. And that makes a scatter plot. That if there's a scatter plot on a graph, instantly you should be thinking slope. We can find the best fit line that goes between that data. That's the line that's on the scatter plot that I already mentioned. And then we can use that to see how good is it for prediction. Notice how that best fit line, best fit it might be, look at how much difference there is between just that line and that one dot, or even like this one, right? Chances are there's going to be a lot of error here, where if instead this looked a lot more like this, and you had the line going through, right? Even if you had just one outlier for some reason, that's going to have a lot less error of prediction than this one that's on the slide there. That area of prediction thing, how is it the best fit line, all that kind of stuff, that's regression, simple regression. There's lots of different kinds of regression. Depending on the field you go in, you may do more regressions than others. Those of you who are looking at doing work that would have you with big, huge data sets, especially like public health, public policy, stuff like that, you're probably going to go way more into regressions, more advanced regressions. For this class, we really just do simple regressions to give you a good foundation to start there. At the very end of the course, we'll talk about hierarchical regressions briefly. Well, there's all sorts of different regressions. So if you hear the word relationship, I want you to think correlation. Relationship even, okay? But if you hear the word prediction, I want you to think regression. Because again, we're going to use that line, that regression line that goes between the scatter plot to make predictions along. So that kind of sets us up for what else is in this module. Then there's also a PowerPoint on regressions and a crash course video on regressions, because that's the other part of the content. So you're also going to go over the lesson that's on regressions. And again, what I want you to be thinking about is regressions may sound scary, but all you're doing is you're saying, hey, these two variables are related to each other. They are, because I've already done the correlation. If they are related to each other, then I can use that relationship to predict. And since there's just two things, that's an XY axis, I can just graph them. And if I can make a graph of dots, I can make a best fit line. And if I can make a best fit line, I can see how best fit that really is. That's all a simple regression is doing. The homework. You've got a worksheet, right? And the first part is the hand calculated correlation. Okay. Now, again, that might look scary. You've got all the formulas there, but there's a whole video lecture that's going to show you how to do one of those by hand. Okay. Remember, if you get to that R, if you do everything, you find your sum of squares X, your sum of squares Y, your SP, and you do everything and you come up with your R value, and that R value is greater than the absolute value of 1.00000 forever, you know you've made a mistake. Because a correlation can only be between -1 and +1. So if that ends up being 16.5, you've made an error. Go back and try to rework it. If it's not Sunday night, email me for help, okay? But you've got a couple of questions there that's about finding the correlation and then interpreting it. And then you're going to use those same numbers to then also do a regression. And again, everything you need to do that is in the regression PowerPoint. Now, here's where something sucks. If you get your answers in question number 1 wrong, because you're using them in question number 2, they will also be wrong. Okay? Don't worry, for the Unit 2 exam, it won't be that way. I'm going to have them as separate things. But for the homework, they're related to each other, to show you that correlations and regressions naturally go together. So if when you take your first attempt, you find out that your correlation numbers are wrong, it means that automatically your regression numbers are going to be wrong. And that's why this week particularly, it's kind of important that you work out the homework and take your first attempt as early as possible in the week, so that if they are wrong, you have time to reach out to me for help before you take your second attempt. That's what we're doing this week.